Welcome back. Over the past few lectures, we have talked about different ways of describing a set of data. With the frequency distribution, like the one that we have here, I noted that there are several things that we want to know about it. We want to know what is the center. We talked about things like the mean, median, mode, trim mean as ways of describing that. Then we talked about the spread of the data, how close it is to the center or how spread out, with measures such as the minimum, maximum, standard deviation, variance, and range. The other thing that we want to know is the shape of the data, and that's what we'll be focusing on today. Now, beyond numerical classifications of a set of data, it can be very helpful to create different visualizations of your data. And there's a lot of different ways that we can do it, depending on the data that we have. This is actually a visualization from a paper that I wrote on personality and data or words that people use on Facebook, and a way to visualize that. This is extroversion here. Now, sometimes we'll use visualizations just to kind of understand things itself. So I might create some different graphics just to try to understand what are the variables that I have, how are people responding on them, what's the general shape of things. At other times, you can use visualizations as part of a report or a paper. They can be a very powerful way to communicate your findings. So why would we want to use visualizations? I think we gain several things. Number one, it helps you interpret the numbers that you get. So if I'm just looking at a set of data, it's very helpful for getting a sense of how people are responding to things. And can help me identify problems with the data. So if I have some really strange scores or strange things that are occurring in the visualization, that can help me see some problems there. And the other thing is, it really helps to communicate findings and the information that we have. People are pretty bad at understanding numbers, and the whole adage, a picture is worth 1,000 words, really comes true. And so you can communicate about numbers very efficiently and in a way that people can really understand. Now, with that comes responsibility. So graphics are very powerful, but you can also misuse them, and so it's something to be aware of, both of how you use the graphics and how others use it as well. So let's dive into a few of the most common visualizations that we use. One that I use all the time, and typically when I start with a data set, it's one that I will graph the different variables and see what they look like, is a frequency distribution. And we have several ones here. Now, a quick look at this is going to tell me a lot about the general shape of how people are responding. Now, this is the distribution that we've looked at several times here, and this is what's called a normal distribution. So it's pretty symmetrical. We have the peak in the middle, and it goes off to either side. In contrast, take a look at this. This is a negatively skewed graph, and so we have most of the scores are clustered towards the higher end, but we have one score that's pulled out towards the lower end. I see this a lot with well-being data, so when people answer a well-being questionnaire, a lot of people might score higher on the scale, but I generally get a few people that are scoring in the low range as well. And then we can have a positively skewed distribution, where in this case, most of the scores are on the low end, and then we have a score off on the high end there. This might be with more depression type information. Also, we see this a lot with things like income. So a lot of people will be within a general range, but then if you end up with like a millionaire in your sample, it'll be very skewed in that sense. Then there's all sorts of other distributions that we can think about. A rectangular distribution is where everyone has a different score, and so you don't really have a mode or a kind of dropping off to either side. The bimodal distribution, that's where there's literally two modes, and so two most common scores there. And oftentimes that actually speaks to almost two sample or two different populations that are there. So for instance, if I measure people's height, oftentimes men on average are taller than women, and so we might see kind of two different distributions that are sort of mushed together, and we might want to actually analyze them separately. Down at the bottom we have what are called J-curves, and these are a very interesting one. I've worked with these a lot when I've looked at longevity, so how long people live. And so what we see is for a long time, maybe just a few people die, but as you get older and older, the chance of death increases rapidly until you have 100% mortality rate. So why do we care about these different shapes? The shape of the distribution influences the statistics that we use. A lot of our statistics are based on the idea that we have relatively normal looking distributions. Each of the other types, there are things that we can do with it, but we need to know what the distribution looks like so that we can apply the right analysis to that. Now, when we think about frequency distributions, these also break down into different types. So again, depending on the type of data that I have. Now, to make this a little bit more concrete, I'm going to go back and look at grades that I might give at a class at the University of Melbourne. So I can give numeric scores, and then it also breaks into different categories. So H1 is highest distinction, H2A on down to a fail grade. So in this case, I've graphed the different categories. And so we have categorical or nominal data, and this is what's called a bar chart. And a few things to notice here. We have the counts, so how many of each of the categories is noted on the y-axis. The categories themselves are on the x-axis, so the numbers don't really matter. We could really switch the order of these, and it wouldn't matter. And typically we put spaces between the different bars, and so this is with more categorical data. Now, what if we have continuous data? In that case, we're going to use, so we might have, our scores range from 0 to 100. In this case, we're going to use a histogram. Here's one such histogram, and we see that there are no spaces between the bars. Our markers might either indicate the midpoint of sort of this interval, or it might mark the lower and upper limits of the intervals. So those are used in different ways, and we have the frequency on the y-axis. Now, we can say, okay, bar charts are for categorical data, histograms are for continuous data, we can have spaces between them or not. In practice, people will kind of mix the two, and it's not that important whether you have spaces between them or the real distinction between these. And so really use whichever one best shows your data and you'd like to look at the best. Now, there are other ways that we can show frequencies, counts as well. This is commonly recognized as a pie graph. And these work very well with categorical variables. And so you're saying what proportion of people are in each of the categories that I have. So they can be good for sharing that type of information. With continuous data, another type we can use is what's called a line graph. This is essentially like the histogram, except instead of using bars, there's a point indicating the midpoint of the interval, and then we can have lines connecting it. Now, with straight frequencies, I don't actually like using this type of graph. With a line there, it almost looks like scores over time. And so for the straight frequency, I do prefer the more bars visualization. But line charts we can use if we're thinking about scores over time, so it can be useful in that way. Another visualization which I've used is a spider plot. This is from one study that I was looking at. So this is job satisfaction, and the red is teachers who were low on job satisfaction, and the blue are those who are highest on job satisfaction. And it's comparing the scores on the different categories or the different variables that I had. Spider plots are very interesting. Some people love them and they think they're great, and others absolutely hate them. And so it's your calls to whether you like them or not. Another visualization, which is pretty cool, used to be used a lot and is actually less common just because they can be a little bit harder with current technology to make them. But they're a really great way of sharing information. That's called a box plot, or a box and whisker plot, also called a 5-point summary. It's a very powerful way of communicating information. In this single graph, it communicates 5 to 6 pieces of information. So the box in the middle indicates the interquartile range, ranging from the first quartile to the third. The median is the line across the middle of that box, or somewhere in that box. And then to get the whiskers, we have the whiskers extend out to the minimum and the maximum. So it shows kind of where most of the data is, and then where it extends out to kind of the highest and the lowest point. Sometimes we include the mean on there as well, not always, but it can sometimes be included on there. So essentially, when we want to describe data, this single graphic gives us kind of all of the key descriptive information that we might want to think about. We can also compare different box plots. This is actually plots for 4 different variables, so agreeableness, conscientiousness, neuroticism, and extroversion. And so we can line them up and we actually see, okay, the interquartile range on each of these variables is pretty close. We see that conscientiousness has a higher mean or a median compared to neuroticism, which is lower in this sample. Now in this one, you also see a few dots there at the top and bottom. Those are outliers, so kind of a bit more extreme scores that we can actually mark on there as well. Now each of these different variables and ways of showing these histograms and frequencies, these are all on single variables. We can also visualize 2 variables together. So we can use what's called a scatter plot, where we have 2 variables and the dot is actually indicating your score on the 2. And we'll come back and talk about those when we talk about correlations a few sessions from now. Now it's your turn. Here's the same set of scores that we've been working with over the past few sessions. Can you create a frequency distribution? How about a box plot? Here's the answers I got. For my frequency distribution, I decided to group things into 5 different categories, but you might have graphed each score, or it could look different from there. I also created a box plot here. The numbers going into that are on the left-hand side there. Yours might look a little bit similar, a little bit different, but this is some way you might visualize those numbers. Now those are just a few of the possible ways to visualize data. Graphs are a powerful way to communicate information. And so, with that comes a responsibility, and it is important that even as you communicate things, that you do stay true to the information that's there. So today was more focusing on the concepts of graphing information. Next time, I'll show you how we can actually make some of these using a simple spreadsheet program such as Excel. Thanks for listening, and I'll see you next time.